Hello there, and welcome. You have found your way to a quiet corner of time, a place to rest your thoughts and let the universe tell you its story. Before we begin our journey tonight, I'd love for you to simply settle in, let your shoulders drop. Let the gentle weight of gravity hold you, a soft reminder that you are here. On a spinning world, in a vast and beautiful cosmos, take a slow, deep breath, and as you exhale, imagine you are releasing the day. Let it drift away like a forgotten cloud. There is no rush here. The story we are about to hear is one of deep, unhurried time. The stars will wait for you tonight. Our journey takes us to the very beginning. Not just the beginning of human stories, or the beginning of our world, but the beginning of beginnings. We are going to drift back through the long corridors of time to a moment before the first second had a name. We are going back to a state of perfect, unbroken stillness. Imagine, if you will, a silence so profound that it holds all possible sounds within it. Imagine a darkness so complete it contains the promise of every star. Before the universe was a place, it was a point. Not a point you could find on a map, but a point that held all of space, all of time, all of reality, tucked away inside itself. It was a silent seed of potential, a universe asleep, waiting for a reason to awaken. It was the deepest quiet imaginable, so let your mind grow quiet with it. Let the world outside fade away. You are about to drift through 13.8 billion years of cosmic history, and it all starts here, in the calm, in the dark, in the gentle, waiting nothing. Let's begin. And so, we rest here, in that perfect, profound stillness. A single point, smaller than any grain of sand, yet holding everything that ever was or ever will be. It is not empty. It is simply latent, a universe holding its breath. There is no time, for there is no change. There is no space, for there is nothing to measure. There is only this state of infinite, gentle compression, a cosmic seed waiting in the soft, dark soil of non-existence. What happens next is not a sound. It is not an explosion, despite the name we have given it. An explosion is a chaotic, violent event, something breaking apart within space. This was different. This was the birth of space itself. It was not a rupture, but a release, a slow, graceful, and yet impossibly rapid, swelling dot. Imagine a single drop of ink suspended in a glass of perfectly still water. And now, imagine that drop beginning to expand, not by bursting, but by unfurling. It stretches outward in every direction at once, its edges soft, its movement silent and inexorable. It does not fight the water. It simply becomes one with it, creating color and form where there was once only clarity. So too did the universe begin its grand unfurling from that single point. Space began to bloom in the very first sliver of a moment, a fraction of a second so small that our human minds cannot truly grasp it. The universe swelled from the size of an atom to the size of a galaxy, and then beyond. It was an expansion faster than the speed of light. But this does not break the laws of physics, for it was not an object moving through space. It was the fabric of space itself that was stretching, carrying everything along with it. Think of a piece of silk, dark and smooth, and on that silk are tiny, painted dots. As you gently pull on the edges of the silk, stretching it wider and wider, The dots move away from each other. None of them are running across the surface. They are simply being carried by the expansion of the fabric they rest upon. In this same gentle way, the universe began to create distance where there was none. It was creating the very concept of here and there. This period of incredible growth is what we call inflation, and it was a profoundly quiet affair. There was no air to carry sound, no objects to collide. There was only the silent, majestic expansion of reality itself, a deep, cosmic exhalation after an eternity of holding its breath. The universe was making room. It was laying the foundation for everything to come, creating a vast, dark stage for the future play of stars and galaxies. And what was this new space like? It was almost perfectly smooth, a near flawless emptiness, yet humming with a ferocious energy. It was hotter than the core of any star, a temperature so extreme that matter as we know it could not yet exist. It was a blank canvas, yet it was not truly empty. It was filled with a shimmering, uniform potential, and within this swelling, something miraculous began to happen. In the very beginning, all the fundamental forces of nature, the rules that govern our reality, were believed to be one. Gravity, the force that holds you gently in your bed. Electromagnetism, the force that carries the light from these words to your eyes. And the strong and weak nuclear forces, which hold the hearts of atoms together. They were all a single, unified, perfect force. But as space expanded and cooled ever so slightly, this perfect unity began to break. It was like a single, pure note of music separating into a chord. First, gravity found its own voice. It peeled away from the others, becoming its own distinct entity. It is the oldest and most patient of the forces. Even in this nascent universe, it was already beginning its quiet, persistent work, a gentle, underlying pull that would one day gather dust into worlds and worlds into galaxies. It is the universe's memory, the force that always remembers to pull things together. The other forces would soon follow, each one separating and finding its own unique role in the cosmic architecture. But for now, in this first, brief, beautiful moment of existence, the universe was a place of pure, expanding energy. It was a graceful, silent, and perfect swelling, a quiet dawn that would stretch on for hundreds of thousands of years before the first true light would be free to shine. So let your own breath be slow and steady, mirroring that first great expansion. Feel the space around you, the quiet air in the room. This very space, this very emptiness, was born in that first silent swelling. You are resting within the echo of the universe's first moments. The stage was being set. The silence was giving way to structure. And the story of everything had, at last, truly begun. The great swelling has slowed. The frantic, faster-than-light expansion has given way to a more measured, graceful pace. The universe is still growing, still stretching, but the initial, breathtaking inflation is over. And in its wake, it has left behind a cosmos filled with an almost unimaginable energy, the pure potential of that first moment, a pressure that fills all of space. There are no stars yet, there are no galaxies, there is only this light, this energy, this simmering broth. Imagine a thick, warm fog on a quiet morning, so dense that you can feel its moisture on your skin. The early universe was something like this, but the fog was not water, it was pure energy. And from this formless, shimmering mist, the very first ingredients of reality began to condense. Like dewdrops on a cool leaf, energy, as it cooled ever so slightly, began to transform. It gave birth to the first particles. These were not the sturdy, familiar atoms that make up our world. They were wilder, more fundamental, more fleeting. This was the age of quarks, of electrons, of photons and neutrinos, a time when the universe was a thick, restless soup of the smallest things imaginable. Let your mind drift into this cosmic broth. It is not chaotic in a violent way. It is more like a bustling, crowded market at dawn, filled with a billion quiet interactions. Tiny particles of matter would spring into existence, born directly from the energy around them. For every particle of matter, a twin was born, an antiparticle, a perfect mirror image, identical in every way, but with an opposite charge. For a brief, beautiful moment, they would exist together, a quark and an antiquark, an electron and a positron. They would flicker into being a pair of tiny dancers appearing on the cosmic stage. They would meet, embrace, and in an instant annihilate one another, dissolving back into the pure energy from which they came. A soft flash of light, a whisper of gamma radiation, was all that was left of their fleeting existence. The entire universe was a sea of these constant arrivals and departures, a billion tiny births and deaths happening in every conceivable space, every single moment. It was a perfect, delicate balance. For every particle created, a partner was created to meet it, and their union would return them to the light. It was a cycle of perfect symmetry, a universe creating and uncreating itself endlessly. If this perfect dance had continued, nothing would ever have been formed. The universe would have remained a shimmering, sterile soup of light forever. But in this perfect symmetry, there was a tiny, almost imperceptible flaw, a slight imbalance, a cosmic mystery we still do not fully understand, for reasons unknown. For every billion pairs of matter and antimatter that were born, a single extra particle of matter was created with no partner. Just 1 in a billion. It was a rounding error in the mathematics of creation. A single note held a fraction of a second longer in an otherwise perfect symphony, but it was enough. As the universe continued to expand and cool, the energy levels of the background light began to drop. Soon, there was not enough energy to create these fleeting pairs of matter and antimatter. The dance began to slow. The constant creation ceased. The pairs that already existed found each other one last time, annihilating in a final universe-wide flash. And then, when the light cleared, something was left behind. That 1 in a billion survivor, the lonely particle without a partner. This tiny remnant, this cosmic leftover, was destined to become everything. Every star, every planet, every cloud of gas, every living being. You and I, we are the descendants of that first subtle imbalance. We are what was left over when all the perfect pairs had vanished. We are the beautiful flaw in the symmetry of creation. And so, the universe was now filled with a thinner but more stable soup, a sea of quarks, electrons, and other fundamental particles, no longer threatened by their antimatter twins. They were free to exist, free to begin the next stage of their journey. The universe was still incredibly hot and dense, a place where these fundamental particles zipped around like restless fireflies in a jar. But as it continued to cool, another threshold was crossed. The strong nuclear force, one of the voices that had separated from that first unified chord, began to exert its influence. It is a powerful, short-range force, like a tiny, unbreakable thread that loves to bind things together, and it began to bind the quarks until this moment. Quarks had been free, swimming independently in the cosmic soup. But now, as the temperature dropped, the strong force was able to catch them. It pulled them together in groups of 3. 2 up quarks and 1 down quark. 2 down quarks and 1 up quark. In that moment, the first protons and neutrons were born. These were the first recognizable, stable building blocks of matter, the very heart of the atoms that would one day form. It was as if the universe had just learned its first letters, the protons and neutrons, from the alphabet of quarks. It could not yet spell words or write sentences, but the fundamental characters were now there. So let your mind rest in this new universe. A universe less than a second old, yet it has already laid its foundations. It has survived its own annihilation. It has created the raw materials for all future complexity. It is a place filled with a soft, residual light and a simmering broth of protons, neutrons, and electrons, drifting patiently in the expanding darkness. The stage is set for the next great act, the formation of the first atomic nuclei, the quiet prelude to the moment when light would finally be set free. But for now, there is just this warm, quiet, and promising soup gently stirring in the dawn of time. The universe is now a few minutes old. The frantic dance of creation and annihilation has passed, leaving behind the quiet hum of existence. The fundamental letters of our cosmic alphabet, the protons and neutrons, have been formed, swimming in a warm, dense sea with their smaller companions, the electrons. And everywhere, bathing everything, is light. An intense, brilliant light. A fog of photons so thick that it traps all of creation within a glowing cocoon. This is a universe you could not see through, not because it was dark, but because it was blindingly bright. The light was inextricably tangled with matter. Imagine being inside a star. Light is everywhere, but it cannot travel freely. A photon, a single particle of light, would be born from the heat, travel a microscopic distance, and then immediately collide with a free-floating electron. It would be absorbed and re-emitted in a random direction, only to strike another electron. An instant later, this cosmic pinball game was happening everywhere, all at once. Light was trapped, held captive by the sea of charged particles. The universe was opaque, a glowing, impenetrable plasma. It was a beautiful prison of light, and in this hot, dense environment, the universe began to take its next quiet step. It began to form the first atomic nuclei. For the first 3 minutes of its life, the cosmos was a furnace, hot enough for protons and neutrons to overcome their natural repulsion and fuse together. This was the era of Big Bang nucleosynthesis. It was the universe's first attempt at chemistry. Think of it as a gentle, cosmic alchemy. A proton, the nucleus of a simple hydrogen atom, would find a neutron, drawn together by the powerful grip of the strong nuclear force. They would bind, forming a stable pair called deuterium, or heavy hydrogen. It was the first multi-part nucleus, the first syllable spelled from the letters of creation. This process was happening all across the cosmos, but it was a delicate one. The universe was still incredibly hot, and high-energy photons were constantly crashing into these newly formed pairs, threatening to break them apart. It was a race against time. The universe had to fuse these particles together before it expanded and cooled too much for the reactions to continue. For a few precious minutes, the conditions were perfect. Deuterium nuclei would find other protons or neutrons. Sometimes, two deuterium nuclei would meet. Through these gentle collisions, more complex structures were built. Two protons and two neutrons would bind together to form an incredibly stable and harmonious nucleus, helium. For these few minutes, the universe was busy forging the elements that would dominate the cosmos for billions of years. When the process was over, when the universe had cooled just enough to quench the fires of this first furnace, the composition of our reality was set. For every 10 protons that remained as simple hydrogen nuclei, about one helium nucleus had been formed, and in the process, tiny trace amounts of lithium were also created. Hydrogen and helium, the two simplest, lightest, and most abundant elements. They were the raw materials from which everything else would one day be built. The universe had taken its first building blocks and constructed something new, something more complex. The foundations were now truly laid, and then a long wait began. For the next 380,000 years, the universe continued to expand and cool, but it remained a dense, glowing fog. The newly formed hydrogen and helium nuclei drifted patiently through the sea of light, carrying their positive charge. And all around them, the free electrons zipped and darted, their negative charge preventing them from settling down. As long as the electrons were free, the light remained trapped. The universe was still a prisoner of its own brilliance. It was a time of cosmic patience, a long, slow, quiet afternoon lasting for hundreds of millennia. The universe was stable, but it was also static. It was a place of potential, but no new structures could yet form. The gentle pull of gravity was there, trying to gather the new nuclei into clumps, but the intense pressure of the trapped light pushed back, keeping everything smooth and uniform. Imagine a vast, still lake at dawn, shrouded in a thick, luminous mist. You know the water is there, you can feel its presence, but you cannot see its depths. This was the universe for 380,000 years, a beautiful, glowing, and formless expanse. But as the eons passed, the universe continued its slow, steady expansion. And as it grew larger, the light within it was stretched. Its waves grew longer, its energy grew weaker. The cosmos was slowly, gently cooling, and it was approaching a critical threshold. A magic temperature, when the universe was about 380,000 years old. It had cooled to roughly the temperature of the surface of a modern star. And at this temperature, the electrons, which had been zipping about with so much energy, were now moving slowly enough to be captured. The electromagnetic force, the gentle attraction between positive and negative, could finally overpower the thermal energy that kept the particles apart. A free electron, drifting near a hydrogen nucleus, would feel its pull. It would be drawn in, not crashing, but settling into a stable orbit around the proton. In that moment, the first neutral atom was born. It was a quiet, profound transformation. All across the cosmos, at roughly the same time this was happening, Electrons were finding their homes, captured by the waiting nuclei of hydrogen and helium. The free-roaming electrons, the ones that had scattered and trapped the light for so long, were suddenly gone. They were bound, and as the electrons settled into their orbits, the universe became transparent. The fog cleared. The photons, the particles of light that had been bouncing from electron to electron for millennia, suddenly found their paths clear. There was nothing left to stop them. In a single, silent, glorious moment, all the light of the early universe was released. It was set free to travel, unimpeded, in straight lines, across the cosmos. This moment is called recombination. It was the true dawn of our universe. It was the moment the cosmos took its first clear look at itself. This ancient light, released 380,000 years after the beginning, is still traveling today. It has been stretched by the expansion of space over 13.8 billion years. Its brilliant, visible light cooled into the faint, invisible energy of microwaves, but it is still here. It fills every corner of space. It is the oldest light we can see, a faint, gentle echo of that first universe-wide flash. We call it the cosmic microwave background. When we point our radio telescopes at the sky, we can still see this light. It is a baby picture of the universe, a snapshot of the moment it became transparent. It is a gift from the past, a message that has been traveling toward us since the dawn of time. So now, let your mind rest in this new reality. The universe is no longer a glowing, opaque fog. It is a vast, dark, and transparent space. It is filled with the simplest atoms of hydrogen and helium drifting silently. And through this space, the first light streams endlessly outward. The stage is clear, but it is also dark. For while the afterglow of creation fills the cosmos, there are not yet any stars to illuminate the void. The universe has been set free, but it has now entered a new era, an era of profound and patient darkness. The great flash has faded. The light that was once trapped within the cosmic fog has been set free, and it streams endlessly outwards, a silent, fading echo of the universe's brilliant birth. The cosmos is now transparent, a vast and open space, but it is also dark, a darkness more profound and complete than any night sky we have ever known. For millions of years, this darkness would reign. This was the cosmic dark ages. Despite the ominous name, it was not a time of fear or despair. There were no knights or castles, no dragons, unless you count the kind made of invisible hydrogen gas. This was darkness in its purest and most peaceful form. It was a universe full of matter, but not yet light. Let your mind drift into this immense, quiet space. Imagine floating in an infinite, expanding sea of cool hydrogen and helium atoms. The universe is a vast, invisible cloud. There are no stars to twinkle in the distance, no galaxies to swirl with gentle light. The only illumination is the faint, ancient afterglow of the Big Bang, now stretched into microwaves, invisible to any eye. There is no sense of time, no clocks, no days, no sunrises to mark the passing of moments. There is only the slow, patient expansion of space, a silent and unending breath. If you could listen, you would hear nothing but a profound, unbroken silence. The universe, after its fiery and brilliant childhood, had settled into a long, deep, and meditative hush. It was a time of stillness before the storm, a long pause, before the universe exhaled starlight. Yet, even in this perfect darkness, this absolute quiet, the universe was not idle. Beneath the silence, it was dreaming, it was organizing, it was becoming ready. For one force, the oldest and most patient of them all, was tirelessly at work. Gravity. Gravity is the great gatherer. It does not make a fuss. It does not shout. It simply pulls. And in this vast, dark expanse, it began to work on the invisible canvas of space. The clouds of hydrogen and helium were almost perfectly smooth, almost uniform in their density. But there were tiny, nearly imperceptible imperfections. Whispers of quantum fluctuations from the very first moments of the Big Bang, stretched across the cosmos by that initial, rapid inflation. Some regions of space were just ever so slightly denser than others. The difference was minuscule, less than 1 part in 100,000. A variation so small it would be like noticing a single extra grain of sand on a vast, endless beach. But gravity noticed, and gravity does not forget. These tiny ripples in the fabric of space were everything. They were the seeds of all future structure, and gravity, with its gentle, relentless pull, began to amplify them. In the regions where the gas was a tiny bit denser, the gravitational pull was a tiny bit stronger, and so these regions began to pull in more and more material from their surroundings. It was a process of almost unimaginable slowness. Atom by atom, molecule by molecule, the gas began to shift. It was like watching cosmic dew forming on an invisible spiderweb, a slow, gentle gathering. But there was a silent partner in this dance, an unseen architect that accelerated the process, an architect we now call dark matter. This mysterious substance, which we cannot see or touch, makes up the vast majority of matter in the universe. It does not glow. It does not reflect light. It does not interact with ordinary matter in any way, except through the gentle pull of its gravity. And its gravity is immense. During the long, glowing era when light was trapped, the pressure of that light had pushed back against gravity, preventing ordinary matter from clumping together. But dark matter felt no such pressure. It was immune to the light. And so, throughout those first 380,000 years, it had already begun to gather. It had formed vast, invisible halos, like great gravitational wells scattered throughout the cosmos. It had created the hidden scaffolding of reality. Now, in the transparent, dark universe, ordinary matter, the hydrogen and helium gas, began to feel the pull of these invisible structures. The gas began to fall into the gentle embrace of the dark matter halos. It flowed in slow, majestic rivers through the empty space, drawn toward these unseen centers of gravity over millions of years. This slow gathering began to form a magnificent, universe-spanning structure, a cosmic web. Imagine a lace of unimaginable size woven across the darkness. Great, long filaments of gas and dark matter stretched for millions of light years, connecting dense knots where the halos were largest. And in between these glowing threads were vast, empty spaces we call voids, eerie, silent regions of near-nothing, where few stars would ever shine. The universe was no longer a uniform cloud. It had a skeleton. It had a structure. It was still dark, but it was no longer formless. And within the dense knots and filaments of this cosmic web, the real work was beginning. The clouds of hydrogen gas, pulled together by the combined gravity of their own mass and the dark matter within them, grew denser and denser. As they compressed, the pressure at their centers began to rise. The temperature began to climb. The long, quiet darkness was coming to an end. The universe was still silent, but it was a silence now filled with a growing tension, a sense that something beautiful was about to happen. In the heart of 1,000, 1,000,000 of these collapsing clouds, a critical point was being reached. The conditions were becoming ripe for the first spark. The first lantern was about to be lit in the endless, dark forest of the cosmos. The age of stars was about to begin. And so, we wait here in the heart of a collapsing cloud of hydrogen, deep within the folds of the cosmic web. For millions of years, gravity has been patiently at work, pulling this primordial gas into an ever denser, ever tighter embrace. The silence of the Dark Ages is now filled with a gathering intensity. The pressure at the core of this cloud is building, a quiet and immense weight. The temperature is climbing, rising through thousands, then tens of thousands of degrees. The atoms are being squeezed closer and closer together, their gentle, random drift transformed into a frantic, energetic dance. The cloud is becoming a protostar, a star in waiting. It does not yet shine with its own light, but it glows with the heat of its own compression, a dull, deep red, visible only to eyes that could see in the infrared. It is a cosmic ember, smoldering in the darkness, on the very edge of ignition. And then it happens, deep in the core, where the pressure is greatest and the temperature soars to millions of degrees. A critical threshold is crossed. To protons, the nuclei of 2 hydrogen atoms are pushed so close together that they can no longer resist. They overcome their natural repulsion, and the strong nuclear force, that powerful binding thread of creation, snaps them together. In that moment, they merge. They become something new, and in that transformation, a tiny amount of their mass is converted into a brilliant burst of pure energy. It is not a loud event. It is a quiet, internal shift. A single, silent spark in the heart of a gas cloud, unnoticed by the vast universe around it. But it is a spark that changes everything. That first act of nuclear fusion releases a wave of energy that pushes back against the crushing weight of gravity, creating a delicate, stable equilibrium. The collapse is halted. The ember has caught fire. A star is born. The first star, the first lantern, lit in the endless, dark forest of the cosmos. Its light born. From the fusion in its core begins a long journey outwards, pushing through the dense layers of gas that still surround it. And when it finally breaks free, it pierces the ancient darkness. A single point of brilliant, unwavering light in an ocean of black. And it was not alone. All across the cosmic web, in the densest knots where the gas had gathered, the same quiet miracle was happening, one by one, then by the dozen, by the thousand. The first stars were igniting. The long night was ending. The universe, after hundreds of millions of years of silence, was beginning to shine. These were no ordinary stars, known to us as population 3 stars. They were unlike anything that exists in the universe today. They were born from the purest gas, the pristine hydrogen and helium forged in the Big Bang. There were no heavy elements, no carbon, no oxygen, no iron to help them cool and form. And because of this purity, they grew to be colossal. Imagine a star 100 times, perhaps even hundreds of times, more massive than our own sun, a true giant, blazing with a furious blue-white light, its surface temperature unimaginably hot. These first stars were magnificent, brilliant, and utterly unstable. They burned through their nuclear fuel with a ferocious appetite, living short, dramatic lives. While a star like our sun will live for 10 billion years, these giants lasted for only a few million. They were cosmic flashbulbs, burning with an intensity that lit up their entire corner of the universe, and their light began to transform the cosmos around them. The powerful ultraviolet radiation streaming from these stellar giants crashed into the neutral hydrogen gas that had filled the universe since the Dark Ages began. It stripped the electrons from their atoms, once again ionizing the gas and making the universe transparent in a new way. This was the era of cosmic reionization. It was as if someone was opening the shutters, one by one, in a vast, dark room, letting the light flood in and chase the shadows away. The fog was clearing, not with a single flash, but with the spreading glow of a million new suns. But the greatest legacy of these first stars was not their light, but their death. When a massive star exhausts the fuel in its core, it dies in a spectacular explosion, a supernova. And the first stars died in the most powerful supernova the universe has ever known. In their final, violent moments, they blasted their contents out into the surrounding space. And those contents had been changed inside the stellar furnace of their cores. The simple hydrogen and helium had been fused into new, heavier elements. Carbon, the basis of life. Oxygen, the element we breathe. Nitrogen, silicon, iron. For the first time, these elements existed in the universe. They were forged in the hearts of these first stars, and then scattered like seeds on the cosmic wind. This was the universe's first act of enrichment. The pristine gas of the cosmos was now seeded with the building blocks of complexity. Every heavy element in existence, every atom in your body that is not hydrogen or helium, was created in the heart of a star that lived and died long ago. You are, in the most literal sense, made of stardust. And this is where that stardust was. First born, these enriched clouds of gas, now laced with carbon and oxygen, could cool more efficiently. They could collapse faster. And they began to form a new generation of stars, population to stars. These were a bit smaller, a bit more stable, and they lived a bit longer. And so, the great cosmic cycle of birth, death, and rebirth began. Gravity pulls in gas. Stars are born. They shine, die, and scatter their enriched contents, allowing even more stars to form. And these new stars were not born in isolation. They clustered together in the gravitational embrace of the dark matter halos, forming the first small, chaotic, brilliant groups of stars. These were the proto-galaxies, the first villages of light in the expanding cosmos. They were not the grand, swirling spirals we know today, but small, lopsided collections of a few million stars, glowing brightly in the dawn of time. The universe was no longer dark and formless. It was alive with light, structure, and the promise of a future filled with galaxies, planets, and perhaps, one day, life itself. The first lanterns had been lit, and their collective glow was beginning to fill the sky. The universe was now alive with light. The first villages of stars, those small, brilliant proto-galaxies, flickered against the receding darkness. But these islands of light were not destined to remain lonely outposts. The same silent, patient force that had gathered the first clouds of gas was now working on a grander scale. Gravity, the great weaver, began to pull these communities of stars toward one another. Imagine streams of rainwater trickling down a window pane. At first, they are separate, each finding its own path, but inevitably they are drawn together, merging into larger rivers, their individual journeys becoming a shared one. In the same way, these first proto-galaxies began to drift along the invisible filaments of the cosmic web. They were rivers of stars, flowing through the dark valleys of space, drawn toward the great intersections where the web was thickest, and where these rivers met. The first cities of the cosmos began to be built. This was not a process of neat construction. There were no blueprints, no cosmic engineers marking out spiral arms with rulers. It was messy, it was chaotic, it was beautiful. When two of these proto-galaxies met, they did not crash in a violent explosion. The stars themselves were too far apart to ever collide. Instead, it was a slow, spectacular ballet that unfolded over hundreds of millions of years. Imagine two clouds of smoke slowly intertwining, their edges blurring as they merge into a single, more complex form. This is how galaxies grew. Their gravitational fields would tangle, pulling and stretching each other into long, flowing tendrils of stars. These are called tidal tails, glowing ribbons of light unraveling into the darkness, a memory of the dance. And while the stars themselves passed through each other like ghosts, the vast clouds of gas within the galaxies did collide, and when they did so with gusto. The impact compressed the gas, shocking it into a frantic burst of new star formation. These starbursts would set the merging galaxies ablaze with the brilliant blue light of millions of newborn suns. It was a cosmic baby boom, sparked by the chaos of the merger. The early universe was a rough neighborhood. It was a time of constant mergers and acquisitions. Small galaxies were devoured by larger ones, their stars and gas folded into the growing city. Some galaxies formed quickly, growing fat on nearby gas and gobbling up their neighbors. Others stalled, stranded in the quiet corners of the cosmic voids, like cosmic WALLFLOWERS. At this stage, galaxies did not look like the elegant spirals or massive ellipticals we see in glossy telescope images today. They were irregular, lopsided, and unrefined, more like space blobs than symmetrical beauties. They were galaxies under construction, their final forms not yet settled, and yet, even in their chaos, they were growing. Slowly, their shapes began to stabilize, nudged by gravity and sculpted by their environments. And the final shape a galaxy took would become a memory, a story of its past written in the language of stars. Galaxies that had a relatively quiet upbringing, perhaps experiencing only a few small mergers and having just the right amount of gentle spin, would slowly flatten into a disk. Over time, waves of density would ripple through that disk, compressing gas and sparking the formation of elegant, curving arms. These became the spiral galaxies, the show-offs of the cosmos, like our own Milky Way. but galaxies that were born from more dramatic and chaotic mergers, where two large galaxies of similar size crashed together, had a different fate. The orderly rotation of their stars was completely disrupted. The stars were flung into random crisscrossing orbits, like a swarm of bees. The gas was mostly used up in the initial starburst. What was left settled into a big, round, puffy collection of older, redder stars. These became the elliptical galaxies, the quiet retirement communities of the universe, serene and unchanging. And so, the universe began to organize its brilliance. The scattered villages of light had merged into towns, and the towns had grown into the great, sprawling cities we call galaxies. They were the new centers of creation, the star forges, where gravity and gas would come together for billions of years to ignite new suns. The universe was no longer just a collection of stars. It had neighborhoods, it had structure, and it had found its grand, luminous form. And so, across the vast, dark tapestry of the cosmos, a billion galaxies were born, each one a unique city of light, a swirling testament to gravity's patient artistry. For billions of years, this great weaving continued. Stars were born, they lived, and they died, scattering their gifts of carbon, oxygen, and iron into the interstellar clouds, enriching the gas for the next generation. The universe was growing older, more complex, more interesting. Now, let us leave the grand view behind. Let us drift away from the cosmic web with its great clusters and lonely voids. Let us choose one galaxy from the countless multitude, a beautiful, but not unusual, spiral galaxy. One that had a relatively quiet upbringing, nestled in a calm corner of the cosmos. A galaxy we call the Milky Way. Let us journey into this galaxy, our home. We drift through its outer halo, a vast, ghostly sphere of ancient stars and dark matter. We pass through its graceful, curving arms, shimmering with the blue light of newborn suns and glowing with the soft, pink light of hydrogen nebulae, are heading for a quiet neighborhood, a place far from the chaotic, brilliant energy of the galactic core. We are heading for the cosmic suburbs, here, about 2/3 of the way out from the center, in a peaceful region known as the Orion Arm. Our story becomes personal. About 5 billion years ago, long after the universe's dramatic birth, a quiet cloud of gas and dust was drifting here. It was not a pristine cloud of hydrogen and helium like the ones that formed the first stars. This cloud was a second, or third-generation creation. It was rich with the heavy elements forged in the hearts of long-dead stars, the legacy of countless supernovae that had lived and died since the dawn of time. It was a cloud rich with possibility. Something disturbed this cloud. Perhaps the shock wave from a nearby supernova, the death cry of a neighboring star, gave it a gentle nudge. Or perhaps it simply collapsed under the weight of its own gravity. Whatever the cause, it began to contract. Slowly, patiently, it began to pull inwards, spinning gently, like water draining from a basin. As it collapsed, the vast majority of its material, the hydrogen and helium gas, spiraled toward the center. Just as it had happened with the first stars, the pressure and temperature at the core began to build. The cloud flattened into a spinning disk, a vast, rotating plate of gas and dust we call a solar nebula. At its heart, a protostar began to glow, a new ember in the galactic night. For millions of years, it gathered mass. Its gravitational pull growing stronger, its core growing hotter. And then, about 4.6 billion years ago, the critical moment arrived. The temperature and pressure in its core became so immense that nuclear fusion ignited. A new star was born. A calm, stable, yellow star. A star we call the Sun. The birth of the Sun sent a great wind of radiation and particles outwards, blowing away much of the remaining gas from the inner part of the solar nebula. But the heavier materials were left behind. The dust, the tiny grains of rock and iron, the legacy of those ancient stars, remained, still orbiting the newborn Sun. And in this spinning disk of cosmic leftovers, the next stage of creation began. Tiny grains of dust began to stick together, drawn by static electricity, like dust bunnies forming under a bed. These grew into pebbles, the pebbles grew into rocks, and the rocks collided and merged to form boulders. Over millions of years, through this slow, gentle process of accretion, these boulders grew into planetesimals, small, primordial worlds a few miles across. The inner part of the disk, close to the Sun, was hot. Only rock and metal could survive here. And so, the planetesimals that formed in this region were dense and rocky. They collided and merged, their gravity growing with each collision, until 4 small, rocky worlds were formed. Mercury, Venus, Mars, and a pale blue dot we call Earth. Our world was born. A sphere of molten rock, orbiting a young, yellow star in a quiet arm of a spiral galaxy. It was a violent, inhospitable place at first, but it was here. It was home, and it held within it all the stardust, all the enriched material from those long-dead stars that would one day give rise to oceans, to an atmosphere, and to life itself. And so, here we are, resting on a small blue world, born from the dust of ancient stars, circling a calm yellow sun in the quiet suburbs of a vast galaxy. For billions of years, our Earth has been a cradle for life, a place of oceans and clouds, of warmth and change. And from this gentle vantage point, life has learned to look up. It has learned to wonder. It has learned to piece together the story of everything, from the first silent swelling to the great weaving of the galaxies. We have looked back in time to the very dawn of creation. Now, let us do something different. Let us cast our gaze forward into the deep, quiet future of the cosmos. Let us drift into the story of what is yet to come. For a long time, we thought the universe had 2 possible fates. It might continue, expanding forever, or the gentle pull of gravity might one day overcome the expansion, pulling everything back together in a great cosmic collapse. But the universe, it seems, had a different plan. When we looked at the most distant galaxies, we found something unexpected. They were not slowing down, they were speeding up. The expansion of the universe is accelerating. It is as if, after throwing a ball into the air, you watched it suddenly shoot upwards, faster and faster, defying the gravity that should be pulling it back down. There is a mysterious pressure at work, a quiet, persistent force that is woven into the fabric of space itself. We do not know what it is. We call it dark energy. It is not a violent force. It is more like a gentle cosmic sigh, an inherent tendency for space to stretch. And as the universe grows larger, there is more space, and therefore more of this gentle outward push. Over billions, Then trillions of years, this quiet force will come to dominate the cosmos, and its effect will be one of profound, unending solitude. Galaxies that are not already bound to us by gravity will begin to drift away, their pace quickening. As we watch them from our future home, they will appear to grow redder, their light stretched into invisibility by the expanding space between us. One by one, they will cross a cosmic horizon and vanish from our sight forever. The night sky of the far future will be a lonely one. Our own local group of galaxies, including our Milky Way and Andromeda, will have long since merged into a single, giant, elliptical galaxy, a great island of stars we might call Milkomeda. But this island will be alone. All other galaxies, all other cities of light, will have drifted beyond our view, lost in the ever-expanding darkness. The universe will become a vast, empty, and silent void, with only our own local, faded island of stars to punctuate the black. The great creative era of the universe will be over. The gas needed to form new stars will have been used up or blown away. The great starbursts and brilliant blue nebulae will be a distant memory. The universe will grow old. The last generations of stars will be the small, cool, red dwarfs. They sip their fuel slowly, burning with a faint, ruddy light for trillions of years, like cosmic embers glowing in the final twilight. But even they cannot last forever. One by one, they too will flicker and die, leaving behind cold, dense remnants, white dwarfs, neutron stars, black holes. The universe will become a graveyard of stars, a dark expanse filled with the quiet ghosts of what once was. The galaxies themselves will dissolve, their dead stars slowly escaping their gravitational pull and drifting alone into the endless dark. And what of the black holes, those final gravitational titans? For an almost infinite amount of time, they will be the only organized matter left, but even they are not eternal. Through a process of almost unimaginable slowness, they too will fade. They will leak their energy back into the void, a faint whisper of radiation over timescales so vast they make the age of the universe seem like a fleeting instant. They will slowly, gently evaporate, and when the last black hole has dissolved, what is left? A universe of almost perfect emptiness, a cold, dark, and silent place filled with a thin, uniformed sea of stray photons, neutrinos, and other fundamental particles, all drifting ever further apart. The universe will have returned to a state of equilibrium, a state of deep, unbreakable peace, a state of quiet, cold stillness, not so different from the one in which it began. And us, we are here now, in this brief, warm, beautiful moment between the first spark and the final, cold silence. We are the universe's way of knowing itself. We are the stardust that woke up, that learned to build telescopes and write stories, that learned to feel love and wonder. Our lives, our dreams, our every breath are a fleeting, precious flicker of consciousness in the vast, cosmic story. We are a brief, beautiful dream of the universe itself. So now, as our long journey comes to its end, let it all go. Let the story of the cosmos, with its fiery birth and its cold, quiet end, simply be. It is not a story to hold on to, but a current to drift upon. Feel the gentle pull of gravity, a reminder of your connection to this earth, to this sun, to this galaxy. You are a part of this story. You are made of its memories, and now it is time to rest. Let the darkness behind your eyes be as peaceful as the long cosmic night. Let your breath be as steady as the spinning of the earth, and let yourself drift off to sleep, a small, dreaming fragment of a vast and beautiful universe. Good night.